Good morning, students. Today we'll try to learn about the integrals, that is integration. Okay, for class 12th. So now we'll try to learn about the integral, that is integration, by using we have learned previously by integration by substitution method. Right now, today we'll discuss about doing integration using trigonometric identities, which we have learned in class 11th. Okay, so now we'll try integration integration using integration using trigonometric identities. Trigonometric identities. Trigonometric identities. Okay, so let us try examples so that we easily able to know how these identities are applied in the numerical to solve the integration. So we have question now: sine square 2x plus 5. We need to integrate sine square 2x plus 5. Okay, so we'll try to solve this. Now sine square 2x plus 5, here we'll apply the identity of cos 2x, which we have learned. That is, we have three identities for cos 2x, but here we'll apply that identity. We all know cos 2x is equal to 1 minus 2 sine square x. Now 2 sine square x is equal to 1 minus cos 2x. Okay, now sine square x is equal to 1 minus cos 2x upon 2. Okay, so this identity, this formula will apply here. That is, I'll write here 1 minus cos 2x. X is here, I have 2x plus 5. Now upon 2. Now we need to integrate this. So what will happen? Take 2 here, half common outside. Now we have 1 minus cos 2. We'll open the bracket. 2 into 2 will have 4x plus 10. Okay, we need to integrate this now. Okay, so what we will do here, we'll integrate minus cos 4x plus 10 dx. Okay, so now my next step will be x by 2 minus, what is the integration of cos x? We all know sin x. So I will have sin 4x plus 10 upon 4 plus c. Okay, so that is how we able to solve the numerical here. That is, the integration of cos x is sin x, and then we need to take this, like how we can do, we can apply the formula for like substitution we have done with taking 4x plus 10 is equal to t. Okay, we all know how we can do this. Take t, so what will happen? Cos t. So now integration of cos t, sin t plus c. What is t here? I have taken sin 4x plus 10. How 1 upon 4 comes here? So as we know, we have done the substitution method, taking 4x plus 10 is equal to t, differentiating it with respect to x. So we'll have 4 dx is equal to dt. So dx will be is equal to dt upon 4. Okay, dt upon 4. So here it comes cos t dt. So now I sin t plus c, and dt dx will be dt upon 4. So that is why I have taken 1 upon 4 here. Okay, so I hope it's clear now. So that is how, this is how we use the trigonometric identity in in such cases. Okay, so now we'll try to solve the next numerical. Now we'll try to solve the next numerical we have, that is sin 3x cos 4x. Okay, now let us see how here we can apply the identity. Okay, how we can apply the identity. So we have the question sin 3x cos 4x. Sin 3x cos 4x dx. Now here we can apply the identity by dividing by 2 and multiply by 2 sin 3x cos 4x. So now here the identity will be applied for 2 sin A cos B. Okay, so we have the formula list. We all know the formula for 2 sin A cos B, that is sin A plus B plus sin A minus B, that is sin A plus B plus sin A minus B. So we'll apply the identity here, that is 2 sin A cos B, that is sin A plus B plus sin A minus B. So here we will write the identity for 2 sin A cos B is equal to sin A plus B plus sin A minus B. Okay, this is the identity. Now I am using it. So now what we can do? Now what will happen? Now we have sin 7x plus sin minus x. So now I have this. Okay, so now we can say, we can separate it, sin 7x dx. Now we all know sin minus x is equal to minus sin x. Okay, so now we can easily integrate. What I have said here, sin minus x is equal to minus sin x. Okay, so now we can do easily. That is, now what is the integration of sin x? Is minus cos x. So we'll have minus cos x and upon 7. We all know how it comes. No, okay, by 7, by taking t like this we have done. So now it will be plus cos x plus c. So now I can write here minus cos 7x upon 14 plus cos x by 2 plus c. Okay, so likewise we can easily solve the numerical using trigonometric identity. Now we'll solve the next numerical. Now we'll try to solve the third numerical. Now let us see what the third numerical they have given here and which identity will be applied in such case. So now we'll try to see that what they have given is, that is cos 2x cos 4x cos 6x, cos 2x cos 4x cos 6x dx. Okay, now let us see which identity will be applied here. Now cos 2x will leave aside and what will do? We'll multiply here and divide by 2. Cos 4x cos 6x. Okay, and so now we'll apply the identity here, that is 2 cos A cos B. So what is the identity for 2 cos A cos B? 2 cos A cos B is cos A plus B plus cos A minus B. So we'll apply here cos a plus b plus cos a minus b. Okay, so I'll got this. So now we all know cos minus x is cos x. So here we'll write the identity. Whichever identity we are using, we need to write here. Okay, so which identity I have applied here? To cos a. What I have applied here? To cos a, cos b. What is that? Cos a plus b plus cos a minus b. Okay, so that is how what we have used that identity here. Now let us see what will happen. Cos 2x, we have just multiplied in the cos 10x plus cos square 2x. So now I have this. Okay, so now what will happen? We'll apply again the identity here. That's what the 2 cos A cos B. So what we'll do? Half into 2 cos 2x cos 10x dx. Okay, now we'll, and here we'll apply the formula, that is cos square 2x. Now we all know the formulas here. Cos 2x, we have 3 formulas, but here we have seen one, that is cos 2x, 2 cos square x minus 1. So we'll apply here. What will happen if I take 1 here? 2 cos square x is equal to 1 plus cos 2x, or cos square x is equal to 1 plus cos 2x upon 2. But here cos 2x, so if I take here 2x, it will be cos 4x. So will what happen? 1 plus cos 4x upon 2. Okay, so that is how we can easily solve this. Now here we will apply the identity. Okay, so it will be 1 upon 4. Okay, now what is the 2 cos A cos B? Same here, cos A plus B plus cos A minus B. So what will happen? Cos A plus B, A plus B, that is cos 12x plus cos minus 2x. Okay, plus 1 upon 1 plus cos 4x upon 2 dx. Okay, now we can easily integrate 1 upon 4 cos 12x plus cos 2x. We all know cos minus x is cos x, plus 1 plus cos 4x. Okay, now we'll integrate according to it. Okay, so what will be the answer here? That is cos 12x is equal to, what is the integration of 12x? It will be, I'll write it here. Okay, we have space. Cos 12x will be sine 12x by 12 plus sine 2x by 2 plus x plus sine 4x by 4 plus c. Okay, so that is how we able to solve the numerical. That is what we have by integrating this. So we have separately integrate them so that we got the answer. Okay, further we can take another step also for, but I think it's sufficient if I multiply here 1 by 4 inside, so it will be 48, 8, and then, or else we can take LCM also. Okay, but it's still sufficient to keep this as an answer. Okay, so that is how we able to apply the trigonometric identity. Now we'll try to solve the next numerical. on the next numerical, what we have in this, let us see what the question is and which identity will be applied. So let us see how it works now. Okay, so we have, so what is the question? Sine cube 2x plus 1. Sine cube 2x plus 1 dx. Okay, so now what we can do here, we can write sine square 2x plus 1 into sine 2x plus 1. Okay, with respect to dx. So we all know sine cube, we can write sine square x into sine x, it will be sine cube x. So now we will use identity for that is sine square x plus cos square x is equal to 1, which we have learned in 10th class. Now we'll apply here. That will be minus cos square 2x plus 1. Okay. So now which identity we have applied, we have to write here. So which we have applied, that is sine square x plus cos square x is equal to 1. Okay, sine square x plus cos square x is equal to 1. So that is the identity which we have applied. So now what we can do here, now use the substitution method. Put cos 2x plus 1 is equal to t, so that minus sine 2x plus 1 dx is equal to dt. So I can write here 1 minus t square, and here sine 2x plus 1, so it will be dx is equal to minus, we are taking now dt. So this is what is, wait, yeah, it's 1 minus t square. We have put cos 2x plus 1 is equal to t. So now by differentiating, it will be dt. So that is how. So now it will be dt. So now what we can do? We can minus multiply, so that it will be 2 square minus 1 dt. So what will be the answer? After integrating, I got t cube by 3 plus t plus c. So now what is t? I have taken cos 2x plus 1. So cos cube 2x plus 1 upon 3 plus cos 2x plus 1 plus c. Okay, so it is how we have used here the identity. So after using the identity, I got my answer. Here I have used a substitution method also, which we have learned previously. Now we'll solve the next numerical. Now we'll try to solve the next numerical. We have sine cube x cos cube x with respect to dx. We have sine cube x cos cube x with respect to dx. So let us see how we can integrate this numerical using trigonometric identities. So we'll have cos qx. Okay, leave cos qx as it is and change sine qx. That is, I can write sine square x sin x. If I multiply sine square x into sin x, we'll get the same thing here. That is sine. That is, I got a sine cube x. Okay. So now let us try to solve this identity, solve this numerical. How we can do? Let us see. Okay. Now I can write sine square x as 1 minus cos square x sin x dx. Okay, so now what we can do, put cos x is equal to t, so that minus sin x dx is equal to dt. So I will have t cube 1 minus t square into sin dx will have dt, but here we will have minus sign, minus. Okay, so now I multiply inside t cube minus t, so 5 dt. Okay, now what we can do, let's try to solve this. I will have this t4 by 4 t6 by 6 using the formula that is x power n is equal to xn plus 1 x power n plus 1 upon n plus 1 in the denominator. So I got my answer. Now I can write what is t I have taken, cos. So I will write cos 4x upon 4 plus cos 6x upon 6 plus c. Okay, so that is how we able to solve such kind of numerical. Okay, so using the trigonometric identity. So now let us go for the next numerical. Now we'll try to solve the next numerical we have. Let us see what the next numerical we have and try to solve it out. So now we have next numerical, that is sin x, sin 2x, sin 3x. Okay, sin x, sin 2x, sin 3x. Okay, so likewise we can solve all kind of numericals using this trigonometric identity. So let us see how we will able to solve it. Take sin x aside, put aside, and try to multiply and divide by this 2 sin 2x sin 3x. Okay, here I will apply the identity now. Okay, now 2 sin a sin b, what is the identity we have? 2 sin a, 2 sin a sin b, that is cos a plus b minus cos a minus b. So here we put cos a minus b, cos a minus b minus cos a plus b, 5x dx. Okay, so now what we will do, we know cos minus x is cos x, but what identity I have used here, I have to write here. So what I have used, 2 sin a sin b will here cos a minus b minus cos a plus b. Okay, so that identity have applied here. Now what will happen, you can open the bracket and multiply sin x with all. So you got sin x cos x minus sin x cos 5x. Okay, now we'll apply another identity. We'll multiply with 2 and divide by 2, sin x cos x by 2. We all know the identity here, 2 sin x cos x is equal to sin 2x. So it happens here we'll multiply by 2 and divide by 2, so that I can write the identity here, that is 2 sin x, we have now 2 sin a cos b. So now we can see here half 2 sin x cos x, that is sin 2x upon 2. Okay, so I have here sin 2x upon 2 here. Okay, so now here what will happen, minus we have dx. Okay, now minus 1 upon 4. Now to sin a cos b, will now apply the identity for this to sin a cos b, that is sin a plus b plus sin a minus b. Sin a plus b plus sin a minus b. So we'll get 4x. Okay, so now this will be dx. Okay, well, apply here the identity now. So now integrating sin 2x, what will happen? Take 1 by 2 outside. So I'll got here 1 upon 4 and sin 2x will be minus cos 2x by 2, minus cos 2x by 2 plus, I will not put c plus c here, I'll put there after solving this. Now I got this. Now we can integrate this. So I will get here what? I will get plus cos 6x upon 24, because I got by 6. So 6 into 4, 24. I'm directly integrating it and multiplying 1 by 4 outside. Inside, sorry. So now here I got, what is the integration of sine? So it will be plus only cos 4x upon 16 plus c. So now I can multiply here and I got minus cos 2x upon 8 plus cos 6x upon 24 plus cos 4x upon 16 plus c. Okay, I have done the integration, that is sin x will be minus cos x, but still minus, so it will be cos x, and by 4x is where, so upon 4, 1 upon 4 into 1 upon 4 will be 1 upon 16. So I have directly integrate them and multiply with the outside constant term. Okay, so that is how we can easily solve numericals, like we do integration using trigonometric identities. Now let us solve the next numerical we have, that is, let us take one complex one now, because I have solved all these numericals are very easy and I hope it is clear to everyone. Now we'll try to solve the more complex one numerical. They have given sin inverse cos x with respect to dx. Okay, now what we can do here, put cos x is equal to t, so that I can write minus sin x dx is equal to dt. But as we know, cos x is, we know the identity, that is sin square x plus cos square x is equal to 1. So I can write here, that is the cos square x is equal to, no, sin square x, we'll take sin square x is equal to 1 minus cos square x. Okay, cos we have taken t, so I can take 1 minus t square. So sin x will be 1 minus t square under root. Here I will put this, so I will got dx is equal to minus dt upon, what I got here, if I take minus sin x there, so I'll got this. So now dx I'll put this, so I'll got sin inverse t, and here by dt I will write here, that is 1 minus t square under root into dt. Okay, so now I have taken this. So now what we can do here, okay, sin inverse t, now put sin inverse t is equal to u, so I got 1 minus sign will take outside. So now sin inverse t is equal to u, so I can put 1 minus t square dt is equal to du. Okay, so it will be t into du. Okay, so that is how we can solve this numerical now. I have taken, sorry, you I have taken. So this is what I have done. So I can write this. Okay, so this is what I have. So now u du. So what is u here? We can take u square by 2 plus c. Okay, now what is u I have taken? So I'll put here sine inverse t upon 2 plus c. But what is t? Cos x. So I will write minus sine inverse cos x upon 2 plus c. Okay, but this is not solved here. We'll solve it now. We all know that is sine inverse x plus cos inverse x is equal to pi by 2. Okay, so now if I take x here, cos x, so sine inverse x is equal cos x, sorry, I have taken here x, that is cos x is equal to pi by 2 minus cos inverse cos x. So it will be pi by 2 minus cos x. Okay, so it will be pi by 2 minus x, sorry, pi by 2 minus x. So now I'll put this value here in this, in first. So what will happen? Now let us try to solve it out. If I put pi by 2 minus x here, so what will be the value? Okay, so wait, u square it is also u square, no? So I will take square here. Okay, so it will take square here I have taken. Now I'll put this value in this. So let us see what will happen, because we see we can't leave the question like this, no, because same thing is coming here, so we need to further sort it out. So now what will happen? Put this value here. So I will just try to solve it here. Okay, so now put this value here. I got pi by 2 minus x whole square upon 2. Okay, right, let us try to solve this. What I got here, so pi by 2 here. Okay, so pi square by 4, if I take minus half here, plus x square minus 2 pi x. 2 in will be pi x will be there, no? Because 2 pi by 2x, 2 will be cancel out. So now what will happen? Here I can multiply and I got pi square by 8 minus x square by 2 plus pi by 2 x plus c. Okay, so that is how we can solve such kind of numerical. See, this is the complex one which we have solved. If I compare this question which I have solved earlier. Okay, so this is how we can easily solve such kind of numerical. So if you have any doubt, you can ask, comment, share, like my channel. So thank you.